Hi, so in this video, I'm going to show you how to represent vectors using I and J notation and in column vector form. So we'll begin with question A, where we're going to write the vector v2. Now we can see v2, we move across 3 in the I direction, given here. So we have 3i, and then we have 5j, when this is the j direction. So 3i plus 5j, where I and j are unit vectors. Now we can write this in column form, in column vector form, where we have the I unit on top, so this is positive 3, and then the j unit beneath it, which is positive 5. So they both represent the same translation, but one is written in I and j form, and the other is written in column vector form. Okay, so for question B, now we have two lots of vector 3. So here we have vector 3, and the two lots means we're going to apply this vector again. So we have, rather than going 3 across, we're going to double it to make 6. And then rather going 1 down in the j direction, we go 2 down. So this would be two lots of 3i minus 1j, which we just write as j. And we can expand these brackets as 6i minus 2j. Now, as we work through lots more examples like this, it's easier to write it in column vector form. I'll show you why. So we have two lots of v3, so 3 and minus 1. And this is 6 minus 2. So again, exactly the same thing we have here, just in column vector form. Okay, so for question C, now we're going to add vectors. Well, actually, it's more like a followed by. This addition means followed by. So what this means is we have vector 4, and then we're going to apply vector 2. So we'll go off here. We can work this out algebraically. So v4 would be minus 2i plus 4j. v2 is 3i and 5j. Well, we can add the I terms together. So we have, when we add them together, we have negative 2 add 3, which is 1i, and then 4 add 5, which is 9j. In column vector form, we could write negative 2 and 4, followed by 3 and 5. So now we'll add together the negative 2 and the 3, which will be 1, and the 4 and the 5 will give us 9. So again, exactly the same thing. Okay, so for question D, now for question D, I'm just going to use column vector form. So we have two lots of V1, so two lots of 5i, so 5 in the I direction, 0 in the j direction, plus or followed by v3. We'll just get rid of this. So 3i and minus 1j. So now we can work out the brackets. So we have two lots of 5 add 3, which is 8, and 0 add negative 1, so minus 1. And this will give us 16 minus 2. So this is a quick demonstration on how to write vectors using column vector form and I and j notation. Okay, so let's move on to question 2. Okay, so for example 2, we're given that vector A is 2i minus j, and vector B is 5i plus 3j. And we've been asked to write these vectors in I and j notation. So we'll begin with question A, and I'm going to write this in column vector form. So we have 3 lots of 2i and minus 1j. So we can multiply this out we have 6 and minus 3. In I and j notation, 6i minus 3j. For question B, a plus b. So a is 2 and minus 1, and b is 5 and 3. So we have 2 add 5, which is 7, and then minus 1 add 3, which is 2. So this would be 7i plus 2j. Okay, so do you want to try and work out questions C and D? You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So for question C, we have B, so 5 and 3, minus 2 lots of A, so 2 and minus 1. So now we have 5 and 3, which is B. We can work this out. 2 lots of 2 is 4. 2 lots of minus 1 is minus 2. So now we have 5 take away 4, which is 1, and 3 minus negative 2, which is 5. So this will give us I, or 1i, plus 5j. And for question D, well, we'll work out the brackets first. So we have 3 lots of A, so 2 and minus 1, minus 5 lots of B, so 5 and 3. So now we have 6 and minus 3, minus 25 and 15. And we're going to work out 1/2 of this, given here. So we have 1/2 of 6 take away 25, which is minus 19, and a negative 3 take away the 15, so minus 18. So this works out as minus 9.5 and minus 9. Okay, so for question 3, we're given 3 vectors, A, B, and C, and we've been asked to show that A plus 3B plus C is parallel to 4i minus j. Okay, so we're going to begin by working out this sum here. So we have A, so minus 1 and minus 2, plus 3 lots of B, so 3 lots of 3 and minus 2, plus C, so 4 and 5. So I'll begin by working this out. So minus 1 minus 2, plus 9 take away 6, so 9 and minus 6, plus 4 and 5. We can work out the negative 1, add the 9, add the 4 in the I direction, which is 12, and in the j direction, negative 2 take away 6, add 5 is minus 3. So in terms of I and j form, this is 12i minus 3j. So now we need to show that 12i minus 3j is parallel to 4i minus j. And we can do this by factorizing out the 3. So we have 3 lots of 4i minus j. So what we have here is a scalar multiple. So 12 minus 3 is a scalar multiple of 4 and minus 1. So a scalar multiple means if we have 4i minus j, we have something like this going in this direction, so 4i minus j, and we had 3 lots of this, it would be the same direction, just 3 lots of a magnitude. Okay? This would be 12i minus 3j. So you can see that the 2 vectors are parallel, just a different magnitude. Okay, thank you very much for watching, and I hope you found that useful. Thanks again, and take care.